Hi, this is Erin, and I'm going to show you how to use the oscilloscope to measure alternating voltages. So I'm going to use this source. It's the V peak source. In my previous video I showed how to change it, but basically you just select properties and you enter into this field how large you want the peak voltage to be, and then we put in 60 Hertz. Okay, and the phase is going to be 0, just because that's just a conventional way to do it. So we're going to make a RC circuit. So if we go to basic, here is the resistor. I'm just going to use the default 1 kiloohm resistor, and then the capacitor, the 1 microfarad capacitor, and then the last thing we need is the ground. So the ground is actually located in the source folder and in power sources. A little bit maybe unexpected, but that's where it is. Okay, and in Multisim you can change how they look. So I'm going to flip this clockwise. So now I can connect the components. So right here I'm basically anchoring it, like I just clicked right there. Like for example, I can click like that. I'm clicking at each thing, and Multisim will kind of store that, but I guess because I like things to look a certain way, I'm going to change it so it's like that. And then you also need to, well, we can just turn on the simulation right now. So we don't have ground connected, and that's basically a consistency error. If you know anything about linear algebra, you kind of want a reference, because we only, because there's a whole bunch of ratios that these voltages could be in relation to, or I'm not explaining this right. So all of our voltages are going to be in reference to a single point, and just to make our calculations easier, we're going to pick a ground, and everything is in relationship to that. Okay, but we could set this to be anything that we wanted, and then all of the relationships, the voltage relationships, would still be the same. Okay, so I have the simulation on. And when that happens, I can't really do anything else. I can't delete stuff. I can move stuff around, but you can't really change the circuit while it is being simulated. So you have to turn it off, and I want to grab the oscilloscope. Okay. So normally, the actual oscilloscope, like in the lab, these two ports are actually connected within the machine, and I'm just going to, even though we could use this as if it weren't connected, it's kind of good practice to get into the practice of saying those are all connected to ground. Okay, and I guess I just changed the color. So if you just right click and select properties and then net color, because this is ground, we can't actually change the name, but that's neither here nor there. So now I'm going to do here and then connect the other one. So just to make it a little bit easier to see, I'm going to change the color again. Okay, and I can actually change this name, so I might call it V peak, just because that's what I do. So if you don't click that box, it's not actually going to show it. So you need to show it, and then you can take it, and then I'm locking the position right there. I'm going to do something similar here. I'm going to call it V cap. Okay, so that's where that showed up. I might just move it here. So these oscilloscopes are used to measure voltage for the most part, and so they're connected in parallel with each component. So these two share the same nodes as the supply, and the red one and the green share the same nodes as the capacitor. Okay, now we're going to turn on the simulation, and you don't see anything until you hit properties. So it is just generating, so I'm going to press pause, and I can't really see what's going on here. I'm going to have to change the scales. So I'm going to change it up to 100. And then the last thing, I also want the time scale to be smaller. That's too small. Okay, and then so yeah, so now you can see peak to peak. Okay.